In this video, we are going to think about creating a dilution. A dilution is a specific and unique type of concentration calculation using concentration. So what is a dilution? A dilution is a way that we can create a more dilute sample. So let's think about how this might look. So in this case, I have a beaker, and we're going to go to different concentrations. So first, I'm going to say that there are, hold on, lost half of our sample. So in here we have 10 dots. And I want to take 50% of this and put it into a solution with the same volume. If I have 10 dots and I take 50% of that, I'm going to take 5 dots. And if I were to take 10% of this into a solution of a similar component, I would have 1 dot. We're going to take 20% of this because that math doesn't work the other way. So one thing you'll notice is that the number of blue dots from left to right, we see fewer in each solution. So the amount of molecule dilutes every single time. So we go from thick, a lot of dots, to less dots, to more dots. There's no way for you to have gone in the reverse. You can't have enough solution to increase the moles of a similarly sized solution. So every time the molecule decreases, so you can go from a concentrated solution, meaning larger, to less concentrated. So you could go from a 3.3 down to a 1.2 molar. There is no way to go in the opposite direction. So we can create a dilution. When we create a dilution, we're going to calculate that concentration using this equation of M1 V1 equals M2 V2. So in this equation, what we see is that moles over liters multiplied by liters equals moles over liters multiplied by liters. So the amount of moles in solution 1 is equal to the moles in solution 2. This makes sense because if you remember back to the graphic on the previous slide, we took a quantity, the equivalent quantity out and just made it more dilute, meaning at a greater volume. Now, this part is really important. I'm going to highlight it in green. This calculation is only for dilutions. Just because this equation allows you to go from moles to moles of one thing to moles of something else, that isn't in fact how we can use this. The thing that is important is that these two components must be the same compound. We cannot just use M1V1 equals M2V2 for anything that we feel like. It must be for a dilution. So let's look at some examples. A lab experiment requires 3.00 liters of a 0.5 molar solution of calcium chloride. How many milliliters of a 10 molar stock are required to make this solution? So I'm going to highlight in green what are the two. So this volume goes with this concentration, and this concentration is the other side. So we always want to make sure that we're measuring the right one. So M1 V1 equals M2 V2. So in this case, we have 10.0 molar V1 equals 0.5 molar times 3 liters. And so that gives you V1 is equal to 0.150 liters. Now, if you look in the question, it asks how many milliliters. So we are going to multiply by 1,000 milliliters in 1 liter to get 150 milliliters. That decimal place allows you to have three significant figures. Alternatively, you could have written 1.50 times 10 to the second milliliters. Either answer would be correct. You just need to know how many sig figs there are. So in this case, what is the volume of a 3 molar sodium hydroxide solution created by diluting 2.2 liters of 15 molar? So in this case, we are going to create M1. We're going to identify those. So we have 2 liters or 0.2 liters of a 15 molar. And the other component is this. So if we write out M1 V1 equals M2 V2, we can see that we should multiply 15.0 molar times 0.2 liters, and that's going to give us 3.00 molar V2. So V2 is equal to 1.00 liters. So we can dilute these any way you'd like, thinking about these components. Just make sure that the components that go together match. Now you might ask, does it matter which one is M1 and which one is M2? It doesn't. You can use those any way you'd like. So let's look at some additional examples. So what volume of a 6 molar sodium nitrate solution should you use to create 0.525 liters of a 1.20 molar sodium nitrate? So in this case, we are going to see that we have 6.00 molar, and that gives us V1. And so we can multiply that by 1.20 molar multiplied by 0.525 liters. So when you solve that value for V1, you get 0.105 liters. Now this question doesn't specify, but if it said in liters, then we would leave it as is. More often than not, it will specify for things that I provide you, and definitely in the homework system. So the next question is, what is the concentration of a solution created by mixing 75 milliliters of 2.25 molar sucralose with, this should say milliliters of water? So in this case, we are going to mix these together. So we're going to have 2.25 molar. In this case, we're going to just leave the volume as 75 milliliters, because as long as the volumes are the same, we don't need that information. Now this one is a little bit trickier because we are mixing 75 mils with 225 mils of water. We're not having a final volume of 225. So M2, now the volume here is 75 milliliters plus 225, which is 300 milliliters. Now you might be asking, do the units cancel? And it turns out that they do, since they're both on the same side. If you had milliliters on one side and liters on the other side, they would not cancel, but you can leave them as is. So M2 in this case is going to be equal to 0.563 molar. Now the reason that we used 300 as our final volume is because the statement says, what is the concentration of solution created by mixing 75 milliliters with 225 milliliters of water? In the previous one, it said to create 0.525 liters. So that's a final volume. So dilution can be used anytime we have the same compound in the stock and in the dilute solution. It cannot be used in any other type of calculation.